Hello, this is Mrs. Ward, and I'm going to go over the 6.3 review class worksheet. So this is the one that we did in class. Find the component form of a vector with a magnitude of 12 in the same direction as 3, -5. So there's two ways I can do this. The first way, when we first did this, we said we were going to find the magnitude of u. So I'm going to go back here and find the magnitude of u. And that's going to be the square root of 3 squared plus -5 squared. And when I do that, I get the magnitude to be the square root of 34. 34 is 2 times 17. It cannot be simplified, so I'm just going to leave it as square root of 34. Then to find, I'm going to now find the unit vector. So to find the unit vector, I'm going to take these order pairs, 3 and -5, and I'm just going to divide it by the magnitude. Now, when I do that, this vector has a magnitude of 1. That's why it's a unit vector. And my final answer is I want my vector to have a magnitude of 12, so I'm just going to simply take 12 and multiply it on the outside. And when I do that, and I distribute, I'm going to get 36 over the square root of 34, and then -60 over the square root of 34. If you rationalize, you multiply by the square root of 34 over the square root of 34, put it in lowest terms, so you're going to get 18 times the square root of 34 over 17, and then this would be -30 times the square root of 34 over 17. If you don't rationalize, we're going to let that slide, so don't worry about rationalizing if you don't want to. The next one, find the component form and magnitude of the vector that has an initial point of -8, -12, and a terminal point of 4, 1. I think I've said this.
When the bell rings here in a few seconds, the bell will ring. You'll have
So now I'm going to find, remember it's terminal minus the initial. So I'm going to take, to find the component form, I'm going to take 4. That's my terminal x minus my initial, and then 1 minus 12. And when I do that, I end up with 12, 13, and that's my vector in component form. Then to find the magnitude of that vector, oh, that's all I have to find, the component form and the magnitude of the vector. So now to find the magnitude of this vector, which we'll call W, because they told me to call it W, I'm going to take 12 squared plus 13 squared. And when I do that, I get W, the magnitude to be equal to the square root of 313. Okay, moving on to number 3, find a unit vector in the direction of 7i, 4j. Remember, this is a linear combination. I'm just going to write it as in component form. To find the unit vector, the first thing I have to do is find the magnitude of v. So I'm going to do that by taking the square root of 7 squared plus 4 squared. And when I do that, I get the square root of 65. To find the unit vector, I'm going to take 7 and 4, and I'm going to divide it by the magnitude, which is the square root of 65. You can leave it like that, or you can rationalize the denominator. Either answer would be acceptable. Oh, whoa, forgot. Linear combination, so the answer has to go back in linear combination. So let's say either one, let's do the first one, 7 over the square root of 65i plus 4 over the square root of 65j. If it comes to you in linear combination, the answer has to end as linear combination. The next one, find the component form of a vector v if the magnitude is 1/2 and it makes with the x-axis is 120. So I'm going to take the magnitude and then I'm going to multiply it by the cosine of 120 degrees, sine of 120 degrees. Those are values on my unit circle, so I should use my unit circle. The cosine of 120 degrees is -1/2. The sine of 120 degrees is the square root of 3 over 2. When I multiply by 1/2, I'm going to get -1/4, and then the square root of 3 over 4. And that's it. I'm done. Okay, the next one, number 5, gives you the formulas. They give you two vectors in component form, -2, -3, and v is -1, -10, and they want you to find 2v plus u. So I'm going to do 2 times v, which is -1, -10, plus u, which is negative 2, negative 3. So to do that, I'm going to take 2 times negative 1, so that would be negative 2, plus that negative 2, and then it would be 2 times negative 10, so negative 20, plus negative 3. So my final answer is going to be negative 4, negative 23. And that's for choice, that's for answer A. The next one, I have u minus 3v. So I'm going to take u, which is negative 2, negative 3, minus, and I'm going to leave that minus sign there, and then do 3v, negative 1, negative 10. So when I do that, I'm going to have negative 2 minus a negative 3, which will end up being plus 3, and then negative 3 minus a negative 10, which will be plus 30. And when I add those, I'm going to get 127. And that's going to be my answer for B. And then the last one, 5u. So 5 times negative 2, negative 3, minus v, which is negative 1, negative 10. So 5 would be negative 10, negative 15, and then minus negative 1, negative 10. So that's going to be negative 10 plus 1, negative 15 plus 10. And my final answer is going to be negative 9, negative 5. Okay, moving on to number 6. Okay, so for number 6, it wants to find the linear combination of the standard unit vector I and j with the initial point of 1, 5 and the terminal point 15, 9. So you're going to do, remember it's terminal minus initial. So my terminal point, I'm going to take 15 minus my initial, which will be 1. My terminal y would be 9 minus my initial, which is 5. And so when I do that, I end up with 14, 4. So that is it in component form, but the question asked me to give it in a linear combination. So I'm going to have to rewrite that as 14i plus 4j. And that would be my final answer. Number 7 says find the magnitude and the directional angle of V is equal to 4i minus j. Round the directional angle to the nearest degree. So the first thing I'm going to do is I'm going to rewrite V in component form and make that 4, negative 1. To find the magnitude of V, I'm going to take the square root of 4 squared plus negative 1 squared. And when I do that, I'm going to end up with the square root of 17. 17 is a prime number, cannot be simplified. When I go to find the directional angle, I'm going to do the inverse tangent. Well, let's start off with this way. Tangent is equal to, the tangent is equal to my B over my A. I'm going to choose to do the inverse tangent when I solve that, negative 1 over 4. You can use that end solve if you wish. When I do that, I'm going to end up with theta equaling a negative 14 degrees. Now, I like to stop and think and see if that makes sense. So this vector 4, negative 1, 1, 2, 3, 4, 1, negative 1 is a vector that's in the fourth quadrant. When I look at this angle, negative 14 degrees, that is a unit, a reference angle. That's negative 14 degrees. So it's also in the fourth quadrant. So since they match, I'm good, and I can just leave it like that. If you wanted to add 360, you could add 360 as well, but let's just make life easier and leave it as negative 14 degrees. Number 8, an airplane has an airspeed of 860 kilometers per hour at a bearing of 148. The wind velocity is 130.35 kilometers per hour in the direction of north 26.67 degree east. Find the resultant speed and direction of the plane. So remember, the plane plus the wind is equal to the ground speed or the resultant speed. So my plane is 860 kilometers per hour. It's going at a bearing of 148. So in bearing, 148 degrees would be down here somewhere. This is 148 degrees. In order to find the proper component form of this vector, I need to change it to a reference angle. So I need this angle based off the x-axis. So if this is 148 degrees, I just need this little chunk from here to here. So I'm going to subtract 90 degrees because that's used in the first quadrant and I don't need that. And when I do that, I get 58 degrees, but since it's a trig angle and it's going down, I'm going to make it a negative 58 degrees. So to find this component form, I'm going to take 860 times the cosine of negative 58 degrees, sine of negative 58 degrees. To do the wind, we'll do the wind here. So the wind is going at a velocity of 130.35 kilometers per hour. And this direction is north, 26.67 degrees east. So in order to do this, I need the reference angle. So I need the angle that makes with the positive x-axis. So I need this angle here. Well, these two angles together add up to 90 degrees. So I'm going to take 90 minus that 6.67. And when I do that, I end up with an angle of 63.33 degrees. And that's the angle I'm going to use. So to find the component form of the wind, which I'm going to add to the component form of the vector, I'm going to take the speed, 130.35, and I'm going to multiply it by the cosine of 63.33 degrees, sine of 63.33 degrees. There should actually be parentheses. I don't like the way I wrote that, so I'm going to when I put that in my calculator, when I take the 860 times the cosine of negative 58 degrees, I am going to get 455.73. Then this will be negative 729.32. And then when I take 130 times the cosine, I'm going to get 58.35 and 116.48. When I add those together, that's going to give me my resultant, or my ground speed, whatever I want to say, however I want to word it. And that's going to give me 514. That's taking the 455 plus the 58. And then the negative 729 plus the positive 116 is going to be a negative 612. So that is a resultant vector. That tells me where that vector is, where that point is. So it's 512 negative 612. So to find the speed, the ground speed, I'm going to find the magnitude of the resultant vector. So I'm going to take the square root of 514 plus negative 612. Remember, if you're going to put that negative sign in there, you have to put in parentheses. And when I do that and take the square root, I get 799.91 kilometers per hour. Now I need to find, it wants the bearing. So before I can find the bearing, I need to find the reference angle. So to find the reference angle, I'm going to say the tangent of theta is equal to the b, which is negative 612, over the a, which is 514. So in order to solve this, you're either doing n solve or inverse tangent. I'm going to choose to do the inverse tangent. And when I do that, I get theta to be equal to approximately negative 50 degrees if I round it to 1 decimal point. So this is my reference angle. So this is a trig angle. So this is going off based off my positive x-axis. It's saying it's negative 50 degrees, so it's going to go down. And this will be negative 50 degrees. I need my bearing. My bearing is based on this being 0, this being 90, this being 180. Well, here I have 50 degrees, and then I need this other 90 degrees. So 90 plus 50, I'm going to have a bearing of 140 degrees. So I can say my bearing is 140 degrees. Or I could say south 40 degrees east, but I don't think anyone's going to do that, so I'm just going to leave it as bearing of 140 degrees. And that ends the review sheet for classwork. If you have any questions, let me know.